Now let's discuss about the next big part of chemical bonding, in which we will discuss about the different steric numbers. So we will be discussing today about the steric number second now. So we know that in a steric number 2, sp hybridization is present and the geometry will be linear and shape is also linear. And some of the example of this type of steric number 2 will be NO2 plus CO2, etc. So this is not very important, but I need to know. Now for the next steric number 3. Here the hybridization that we will get here will be sp2 and the geometry will be trigonal planar. And so this is the geometry here, trigonal planar, or this is the geometry. In mistake number 2, this type of geometry is present, linear. Now but we also know that the trigonal planar has two shapes. So one will be trigonal planar and its another shape will be bent. Now let's take an example, and this 3 bond pair plus 0 lone pair. So this type of A, B, B and B, this type of molecule are present here, and in another 2 bond pairs and 1 lone pair can be present here. So the molecule will become A, B, B and a lone pair. So this is V shape or bent shape or angular shape, and their geometry will be trigonal planar, and this is the trigonal planar geometry. Now let's discuss about the next steric number, which is important steric number 4. Here the hybridization that we will get is sp3 hybridization, and the geometry here will be tetrahedral. So tetrahedral geometry, and here we can divide this into 3 parts. What will be these? So 4 bond pair and 0 lone pair, 3 bond pair plus 1 lone pair, and 2 bond pair and 2 lone pairs are present. So this type of molecule can be present here. So as you can see, when putting this, one molecule is here, 1, 2, 3 and 4. This is the structure of trigonal tetrahedral. All this angle will be 109 degree. So here geometry and shape both are tetrahedral, TD in short. And now let's talk about the 3 bond pair and 1 lone pair condition. So when 3 bond pair and 1 lone pair are present, we will get a trigonal pyramidal structure. Trigonal pyramidal shape. And in the 2 bond pair 2 lone pair molecule, as we have seen in the case of water, this is H and this is oxygen. So we know that it has 2 lone pairs, so the shape will be bent and V shape or angular shape. And now let's discuss about the steric number 5. So in steric number 5 we will see the hybridization of sp3 dehybridization. And here there are two type of geometry can be possible. Which one will be, if the dz square is present and dx square minus y square is present, if this bond are present, then square pyramidal will be formed. And if dz square is present, then trigonal bipyramidal is present. So this is very common, and these are very rare. Not too much molecule can form this. So here this type of geometry are present here. One molecule will be in the center, one here, one here, one here, one here, and one will be above in the 90-degree of this plane. And in a common trigonal bipyramidal, the structure will be one will in the middle, one in the right, one in the, these three are in the plane, and one in the above and one in the below. So this is the very commonly formed trigonal bipyramidal structure. Now let's discuss about these bonds. These are called axial bond, and these are called equatorial bond. Generally, their distance will be the distance will be shorter in equatorial as compared to axial bond. So we know that the electronegative group will try to attain this equatorial position. Why? This axial position, because of the percent S character. So why some molecules prefer to position in the axial position and some prefer to position in equatorial position. This is selected with the help of site selection rule. So this is only applicable in TBP. According to this, percent S, if percent S is less in beta B, these are the example structure, and here percent S is less, and in this position percent S is 4. So this is percent S file, and this is percent S file, and this is percent S less, so it is percent S non-file, or more electronegative group or monovalent unit prefer this position, and the percent S non-files percent S files such as less electronegative group and triple bonds or lone pair or double bond or electropositive element, elements are present here. Now, so this tendency of this electronegative group or the electronegative element is to the position in the axial position are called apicophilicity. So apicophilicity is the tendency of electronegative element to occupy the axial position. So apicophilicity का order अगर लगाएं हम, so order of apicophilicity, which is equal to the fluorine will be more than chlorine, then bromine, then oxygen or iodine. So this is the order of apicophilicity. Now in this slide number 5, sp3d, we will discuss about the shape and geometry. So we can divide this into 4 positions, in which 5 bond pair are present plus 0 lone pair, 4 bond pair plus 1 lone pair, and 3 bond pair plus 2 lone pair, and 2 bond pair and 3 lone pair can be possible. So their shape will be all trigonal bipyramidal, but their geometry will be different. So here 1 2 3 4 5. So these are the TBP geometry, and if four bond pair are present and 1 lone pair are present, so this is the structure of the geometry. The shape, its shape will be trigonal bipyramidal, and here shape will be seesaw. What's a seesaw? It's just like seesaw shape. 1 will be here and 2 will be in this direction. So this is just like a seesaw. So these are the seesaw shape. Here in 1 lone pair are present and 4 bond pair are present. And now let's discuss about the 3 bond pair and 2 lone pair condition. So their structure will be just like this. 2 bond pair are present and their shape will be T shape. This is called T shape structure. Now for the last, this will be 3 lone pairs and 2 bond pairs. So 2 bond pair are present here, 1 central atom here, and 1 lone pair, 1 lone pair, and all the 3 lone pair are present here, and that 2 bond pair are present in the axial position. So their shape will be, these are called linear. So there are some example of calculation the shape of the molecule, such as Xe(F2). We need to calculate the shape of the molecule. So before knowing the shape, we first need to calculate the hybridization. So how many unpaired electron present in Xe(F2)? So it came in the noble gas configuration. So there has been how many 8 number of electron, 1 2 3 4 5 6 7 and 8, and 2 fluorine are present, and 1 2 3 lone pairs are present here, 3 lone pair and 2 bond pair position. So this will be the example of sp3d2 sp3d hybridization, and shape will be linear. Hybridization sp3d and shape will be linear. In the same hybridization or the geometry, we will see an important concept which is called Barry pseudo rotation. So what's a Barry pseudo rotation? So these are the fluxonial behavior arises due to energy similarities. Both have the same energy difference, so fluxonial behavior can be seen in the room temperature. So let's take an example of P, F, F, F and F and F. So here A is equal to B. What is AB? Means the size. If consider X is A and is considered as B, if the size of these are all equal, then this bond, axial bond and equatorial bond, both are if the both bond are equal. So here the rapid exchange of this axial and equatorial bond can be seen. This can only be seen into the PF5, only can be seen in molecule of PF5. It cannot be seen into the molecule of PCl5. Why? Because the electronegativity M1 is not equal to B. So there the bond angle that is present between the P and Cl in axial and equatorial are not equal. A will be greater and B will be smaller. The reason is simple. Why? Because in PF5 or in PF5 and PCl5, the energy difference between the SP and TBP will be, or the square pyramidal or the trigonal bipyramidal, energy difference is very less. And in case of PCl5, the trigonal bipyramidal and the square planar geometry, the energy difference will be large. So Delhi here will be large. So we cannot see Berry pseudo rotation in case of PCl5. And by increasing the temperature, we cannot change the energy gap between these. Why? Because the bond strength of PCl5 will broke and it will form if you put the more energy here, just like in PCl5 molecule. If we put a little bit of heat, or if we increase the heat here or the temperature, then this will form into PCl3 plus Cl2 alone. So this is the final reaction that can be seen in case of PCl5 molecule. Now let's discuss about the next steric number, which is 6. So here the hybridization that we will be getting here will be sp3d2, and the geometry will be octahedral. So the normal geometry that we can see here will be 2, 3, 4, 5, and 6. This is the normal geometry of octahedral. If we calculate the number of or the bond angle that are present in this molecule, so we will get 6 C2s, which is equal to 6 factorial upon 6 minus 2 factorial into 2 factorial. So if we solve this, 6 into 5 into 4 factorial upon 4 factorial into 2 factorial, so this will cancel out, and this 2 will multiply this with 3. 3 into 5 will equal to 15. So total number of bond angle will be 15. So there are 490-degree angle present, 490-degree angle of up and down are present, and 490-degree angle of plane in plane mein. This is from up, this is from down, and 3 180-degree angle are present in between this. So total number of angle will be 15. Now let's discuss about the lone pair and bond pairs. So it has 6 bond pair plus 0 lone pair. The geometry will be octahedral and shape will also be octahedral, and the structure, as we can see, is the previous that we have made. So these are the octahedral structure. Now if we discuss about the next, which is 5 bond pair plus 1 lone pair. So the geometry will be octahedral, but shape will change into square pyramidal. So square pyramidal will be the shape. And how does it look like? So one square will be formed and one will be at the top. This is the structure of square pyramid. One lone pair will be in the downside. Now if we talk about the next, that is 4 bond pair plus 2 lone pair are present, then the geometry will be octahedral, but shape will change into square planar. What is a square planar? So the 4 molecules are present in the plane and 2 lone pairs are present in the up and down. So this is the structure of molecule. Now if we talk about the steric number 7, so here the hybridization will be sp3d3 hybridization, and the geometry that we will be getting here will be pentagonal bipyramidal. So how does it look like? A pentagon will be formed, and one at the top, one at the bottom. So these are the geometry of pentagonal bipyramidal molecule. If we calculate the bond angle here, so it will be equal to 7 factorial, or the 7 C2s, which is equal to 7 factorial upon 7 minus 2 factorial into 2 factorial. So 7 into 6 into 5 factorial upon 5 factorial into 2 factorial. So this will cancel out. This 2 3 7 3 is 21. So 21 bond angles are present in this geometry. Now let's discuss about the next steric number, which is 8. So in steric number 8, we will get the two hybridizations, which are sp3d4 or p3d5. These two hybridization can be possible in steric number 8. So when can we see this hybridization and when can we see these? So when s plus 3p plus dxy plus dyz plus dzx plus d. This d can be possible as dx square, y square and dz square. So here AF8 and or the square anti prismatic and dodecahedral, which is AO8 minus n, which is equal to MoCN8 minus 4. So this is the structure of this kind of steric number, which is very rarely seen. Just like one I is present here, and one fluorine is here, one fluorine is here, one fluorine is here, one fluorine is here. So this type of molecule, one 4 member from the top and 1 4 in the bottom. So this is the structure of square anti-prismatic. And if we talk about dodecahedral, so this is the structure of dodecahedral. Now let's discuss about the exclusion of s orbital in case of here. When do we do not count this s orbital? So the example of this type of compound will be XeF8 2 minus. This is the example of this type of molecule. Why? Because the one lone pair we do not count here. Fluorine is small, but number of F is more. So geometrically shape is equal to a square anti-prismatic.